I'm Sami.
And I'm Ella.
And we're going to explain how to do an inverse of a 3x3 matrix. So here we have our original matrix, and we want to find a to the negative 1 power. So what we're going to do is we're going to expand by minors. Now what you do is first we're going to find this spot, which is going to go over here. And you're going to cancel out this row and this column, which leaves you this to find the determinant for. You're going to do that for each of them, and I've already done that for you. So Ella's going to explain how to find the inverse.
So to find the determinant of these, you want to take AD. So let's say that this is A, and this is B, and this is C, and this is D. So you want to take AD minus BC to find each one. So in this case, A times D would be 0 minus B times C, and 4 times 6 is 24. So 0 minus 24 is negative 24. So the first number up here will be negative 24. And you do the same thing for each one. So 0 times 0 minus 4 times 5. 4 times 5 is 20. 0 minus 20 is negative 20. 0 times 6 is 0 minus 1 times 5, which is 5. So negative 5. 2 times 0, which is 0, minus 3 times 6, which is 18, so negative 18. 1 times 0, which is 0, minus 3 times 5, which is 15, so negative 15. 1 times 6, which is 6, minus 2 times 5, which is 10, so 6 minus 10 will be negative 4. And 2 times 4, which is 8, minus 3 times 1, which is 3, so that would be 5. 1 times 4, which is 4, minus 0, so that would be 4. 1 times 1, which is 1, minus 0 would be 1. And then Sammy's going to explain your next step.
Okay, so the next step is to turn these into the appropriate numbers. So what we do is we follow this rule by 3x3. And what we have is plus, minus, plus, minus, plus, minus, plus, minus, plus. And so you're going to apply each of these to each number. So positive times a negative is still a negative, which means that this matrix is going to become negative 24 still. Then we do a negative times a negative, which means that negative 20 will become 20. Then positive times negative is still negative, so it means it'll still be negative 5. Then negative times negative means that it's going to become a positive, so it's positive 18. And then positive times negative is going to become negative 15 still. And negative 4 times the negative will become positive 4. Oops, that's a bad 4. And then positive times positive, it will still be a positive, so positive 5. And then negative times positive 4 becomes negative 4. And then positive times positive will still be positive, so we'll have positive 1. And this is the matrix that we'll be using to find the final inverse.
So the next thing that we're going to be doing, just a pen, is we're going to be switching the numbers here. So we're going to take all the diagonals will stay the same. So we're still going to have negative 24, negative 15, and 1. And then we're going to switch each of these numbers. So 20 is going to switch with 18, and 20. Negative 5 is going to switch with 5, so we'll have 5 and negative 5. And 4 is going to switch with negative 4, so negative 4 and 4.
Okay, so the next step will be doing the diagonals, which the diagonals of A, which is the first two columns of A, and that'll be 105, 216.
Times A, which is the determinant.
Times A to get the determinant. And because this is a 3 by 3 and a 3 by 2,
next thing we're going to do this times A. Times A.
Yeah.
Not that one.
Yeah, I know.
Okay.
Okay. Okay. Oh, it doesn't even show, so it doesn't matter. Okay. Woo! Pretend. Okay. So, and we'll get this out. Okay. Okay. So, this times the first two columns. 1, 0, 5, 2, 1, 6. Okay. And we're going to multiply these. Remember that because this is a 3 by 3 and this is a 3 by 2, the middle is equal, which means that the outside numbers will create the new matrix, which will be a 3 by 2.
It's not going to be a matrix, it's going to be a number.
Dang. Okay.
It's going to be a number. Okay, so
let's cancel this.
Sammy was just kidding. We're going to do diagonals. So 1 times 1 times 0, and we're going to do 2 times 4 times 5, and 3 times 0 times 6. And then we're going to do the same thing backwards. So, and then we're going to subtract the way that we went this way from the way that we went this way to get our final number, which is the determinant of this matrix, which we're going to multiply 1 times the determinant over this, or times this matrix, to get our final answer, which is the inverse. So 1 times 0 is going to be 0. So we're going to have 0 plus 2 times 4 times 5, which is 8 times 5, which is 40. So 0 plus 40. And 3 times 0 times 6. So 0 times 6, so that's 0. So we have 40 up here. So then we're going to go back. So 3 times 1 times 5 is going to be 15. Plus 1 times 4 times 6. So 1 times 4 is 4, and 4 times 6 is 24. So we have 15 plus 24. And 2 times 0, which is 0, times 0 is 0. So plus 0. So we have 40 minus 15 plus 24. 15 plus 24 is 39. 40 minus 39 is equal to 1. So to get our inverse, we're going to do 1 over the determinant, and our determinant is 1. So we're going to do this number, this matrix here, times 1 over 1. And 1 over 1 is equal to 1. So our inverse of our original matrix A is equal to this number here, or this matrix here.